Hello there, Paul Watts, High Flying Physics, targeting top grades at A-level physics. In today's video, we're going to have a look at vector addition, probably the single most important subject in the A-level physics syllabus. It comes up in countless other topics. Over the years, I have set this question, and probably it's fair to say that even my most able students have ended up slipping up on this one. So let's have a look at it. In this question, we have a rower that can row at a velocity of 6 meters per second. She wants to cross the river directly from A to B at right angles to the river current. The interesting thing about this question is that the question is giving you the resultant vector at the start. We'll come back to that in a minute. The river flows at 4 meters per second in that direction. First question, as always, is draw the vector diagram. So we can start off with that 4 meters per second river current velocity. We know the resultant, so we're going to draw the resultant on because we know that that's going to be the outcome of the rower setting off in that direction. And she's going to be rowing at 6 meters per second. So there's our vector diagram. In part B, it says calculate the angle to AB she needs to travel in order to arrive at point B. So we're interested, obviously, in that angle theta. So we use basic trigonometry in that sine theta is opposite over the hypotenuse. Opposite the angle, we've got the 4 meters per second vector. The hypotenuse is the rowing velocity, which is 6 meters per second, and that comes out to be 0.67. Theta then comes out to be 42 degrees. Part C, calculate her resultant velocity. So using a little bit of Pythagoras, what we can say is that 4 squared plus the resultant squared, that's going to equal the hypotenuse squared, which is the rowing velocity, which is 6 meters per second squared. Reorganizing that, we can say the resultant is the square root of 36 minus 16, and that comes out to be 4.5 meters per second. Well, there we are. I hope that's been useful. As I've said, the issue with this question is that the fact that they give you the resultant velocity in the question, and you've got to work out the vector that contributes to that resultant velocity. I hope that's been of help, and we'll see you soon. Thanks. Bye.